This is a 2011 Hyundai Tucson. It's known in some markets as the iX35, and we have an entire playlist of repairs for this vehicle because it just requires constant repairs all the time. In this video we are replacing the AC compressor. The AC compressor is down at the bottom under the alternator that you can see right there. Why are we replacing the compressor? Because the AC stopped cooling. The first thing we did was we checked the status of the AC the AC compressor relay. You can see it on this map right here. It's the blue one on the bottom, and we actually swapped these two that are identical between the fuel pump and the air conditioner, and this did not make any difference. So then we hooked up our gauges, high side and low side, and we verified the level of coolant, refrigerant in the system, and without even turning the air conditioning or the engine on, it's pretty clear that there was a sufficient level of coolant, refrigerant. There's like 100 psi worth, and that is more than enough to turn on the AC in a normal situation. So looking down in here with the engine running, which it is not right now, but with the engine running, you can sort of see the AC clutch pulley, and you can tell whether it is engaged or not engaged. And it did look like the AC clutch was engaged. So with the AC clutch engaged and a sufficient level of coolant, then this system should be cooling, but all it was blowing was warm air. It was not cooling at all. So then to go further with the diagnosis, I used this scan tool, and with this vehicle there is a feature in the scan tool where you can turn the AC compressor on and off. So I was able to turn the AC compressor on and verify that it was coming on, and with the AC compressor running as commanded by the scan tool, I verified that there was no cooling taking place, even with the clutch engaged as commanded by the scan tool and verified visually. So if you know a little bit about AC, and as they say, a little bit of knowledge is a dangerous thing, you might be asking, well, how is it possible that if you have enough refrigerant and the compressor is running with the clutch engaged, how is it possible that you get no cooling? So here's the answer. With these compressors for this vehicle, as with many other relatively newer vehicles, there is a feature of the AC called the pressure relief valve, and this is it right here. And this pressure relief valve is controlled by the ECU, and if something goes wrong with this pressure relief valve, then the compressor will not build up any pressure, even with the clutch engaged. And that is why we have no cooling in this car. By the way, this compressor is an A premium product. This is a line of automotive products that I've had a lot of good results with. This is the part number, and I will include a link for this compressor in the video description. It is priced very fairly and very affordably, and I think these products are of very good quality, and I've never had any problem with them. Okay, with this preamble out of the way, let's get down to business. Our first step is to suck out all the refrigerant, and we use this AC recovery machine to suck it out into this little cylinder. And just so you believe me, here it is in action. You can hear the motor running. And here you can see we've actually sucked down with a little bit of vacuum. I've removed the front passenger wheel and the undercover and the side cover. This gives me access to loosen the belt. The tensioner is right up here. I'll show you in a minute. And it also gives me access to the compressor to remove the lines and the electrical connectors from the compressor. So So the tensioner pulley is right above the crankshaft pulley there, and it has a 17mm hex on it. I've loosened the belt and taken it off of the AC compressor pulley, and I'm leaving the belt in place running over all the other pulleys. I'm not going to remove it because it's as hard as hell to put back. Next I have this bottom line right here, and there is the top line right there, and there's the electrical connector. I've removed the 2 bolts for the 2 AC lines, and now the compressor itself is held with 3 bolts, 2 on the bottom and 1 right up there next to the connector. And all of these bolts are 12mm head. Oops, I lied. There is 1 more bolt. It is up here, and you cannot see it until you get the lines out of the way. It's very hard to see even. Another 12mm bolt, mounting bolt for the compressor right up here where I'm tapping my finger. Here is my old compressor and my new compressor side by side. They seem to have all the same features. The only difference I'm seeing is that these locator pins on the old compressor, they are not here on the new one. So what I'm going to do is pull them off and just tap them in to their locations here. Before I install the compressor, I always pour out whatever oil is inside the compressor, and I do this by just tilting the compressor and spinning the clutch. And for the reasons that I do this, number one is that I do want to verify that there is oil in the compressor and how much, because you never know. Hey, somebody on the assembly line might have forgot to charge this one up with oil. And also, who knows what kind of oil is in there or how long it's been in there. So I'm going to replace it with fresh oil. And this one came with just over 2 ounces in it. It's like 2.5 ounces, almost 3. So I'll put in 3 ounces of fresh POG 46. This compressor came with 2 new O-rings, so I'm going to use them to replace the 2 O-rings that are on the lines right now. The new compressor is in. The lines are both connected. You can see them. The electrical is connected and the belt is back on. So now we're ready to run vacuum on the system and then charge it with refrigerant and check the function of the AC. I'm putting the AC under vacuum with this vacuum pump. You can hear it running. Here you can see my gauges showing that I've drawn a vacuum on the system. I've closed up the manifold ports. I've shut off the pump. Now I'm just going to let it sit under vacuum. The purpose of doing this is twofold. The first one is to suck out any moisture that may be in the system. And by holding it under vacuum, then the moisture will flash off into a vapor form and then it can be sucked out. And the second purpose is obviously to check for any leaks in the system, because if there are leaks, then it will not hold vacuum. I've recharged the system. The engine is running with the AC on. I put enough refrigerant, so at idle, I'm up to about 225 psi, a little bit less, 220 on the high side. And inside the cabin, I use this temperature gauge to verify that my temperature coming out of the vents is in the high 40s, mid to high 40s, which is certainly cold enough for AC. That's it for this video. We have a successful replacement for the AC compressor. The temperature inside the cabin is what most people would call ice cold. So it's good to go. And thanks for watching. If you have any questions or comments, please leave them below.